Okay. Now, given a graph like this, okay, this is the function f of x. So tell me, what is the limit of the function f of x when x approaches -4? Perfect, 2. How about the limit of the function f? What is the value of f of -4? Oh, it's not defined here, right? Because at -4 we don't know yet. But let me just put one more point right here, the solid point here. It means that f of -4 is 1, right? And look at this. The limit of this is not the value of this. Different. So how about limit of the function f of x when x approaches negative from 2 minus? Perfect, 1. How about the limit of the function f of x when x approaches 2 plus? 3 here. Yes, 3. And the left and the right limit are not identical, right? What does it mean? It does not exist. Very good. So how about the value of the function f of x at 4? It's not defined. Yeah, this is the whole right here. So f of 4 is not defined. How about limit of the function f of x when x approaches 4? 2, yes, because both limit from the left and the right approaches 2 right here. So there is a limit, but the value at this value, it is not defined. So be careful. So these points are not good. Okay? Because sometimes the limit is different from the value of this, whatever. And this function, we call it this point when x is equal to plus or minus 4 or 2 are not good. for the function. But at this point, at 5 here, the limit of the function does exist. It is 2 point something right here in the middle, right? And the f of 5 is defined. So we call this point a good point. And these points, we call it continuous points. It means that whenever we draw a function, we don't have to take off our pens and we can draw it continuously. Okay, we call these are continuous points. A precise definition of limit is written like this. For at any point x is equal to a, the value of this is L right here. For any small, arbitrarily small value epsilon, we will always be able to find the delta, which depend on this epsilon, and make sure that f of evaluate the value of the point x here in this range will always be smaller or equal to smaller than L plus epsilon and larger than L minus epsilon. That is a precise definition of limit. Take home, read it, and try to understand it. This part, this notes is uploaded on Moodle, so you can download it. So you don't have to write this part here. And we defined, so the function f is continuous at a number a when the limit of this function when x approaches a is equal to exactly the evaluation of f at a. So this implies that f of a should be defined. And the limit does exist. It means lim for left-hand side and right-hand side limit are equal to each other. And it is f of a here, right? From this definition, we have another smaller definition. F is continuous from the right of a number if limit from the right side is equal to f of a. It means that suppose this is the graph of a function f of x, somehow like this. And this is our point A. We go from the right side. The limit of this is exactly the value f of a right here. This point does belong to the graph. Okay. Similarly, another concept is the limit from the left side. Suppose this is a f function and the point A is right here, then x approaches a from the left, f of x approaches this value. Okay, this is the left side and hence right side limit. Or in other words, the function is continuous if we can, in general, in an interval from A to B, A and B are any numbers. The function f of x is continuous in this interval. It means that we can draw that function continuously without taking our hands on this, right? And at this point, at the endpoints, at A, we should apply the right-hand limit or the continuous from the right. And here at the point endpoints B, it is continuous on the left. So this is the definition of this. So I think tomorrow we will continue with some example, and this is some concepts we need to know in advance. Okay, read the book, and I'll see you tomorrow. Thank you. See you all. Bye bye.